Hello everybody and welcome back to Applied Advanced Calculus. I am your host, Nathaniel Posesorsky, and today we are going to be looking at line integrals. So for line integrals, what we want to do is we want to basically split them up into segments. Segment C1, C2, C3. Also, if we're asked to find the work and we have a closed graph, we could find the work by doing the line integral of FDR. If the work is equal to 0, well then it is conservative. Now, to look at an example, f is equal to 2x dx plus 3y dy. It's important to know that I and dx are the same thing, and j and dy are the same thing. Then we are also given C1, where x is equal to t, y is equal to t squared, and t is between 0 and 1. So if we look at C1, if x is equal to t, well then dx is equal to dt. And if y is equal to t squared, well then dy, which is the derivative of y, is going to be equal to 2t dt. Then, if we plug in what we just found into our f, we get f is equal to 2t dt plus 3t squared times 2t dt. Finally, if we want to find the line integral, we're going to do the integral from 0 to 1, because we were told that t goes from 0 to 1, of the f that we found just on top. If we calculate the integral, we get a final answer of 5 over 2. Another example is this one right here. If we look at this example, we're given x squared plus y squared is equal to 9. This is the equation for a circle of radius 3. 3 being the square root of 9. If we look at C1, going from minus 3, 0 to 3, 0, we see that the y does not change, which means y is 0, and thus dy is 0. So if we look at our f, which was x squared plus y squared times dx plus x squared plus y squared times dy at the bottom, well, our y is 0 and our dy is 0. So the line integral for C1 is simply going to be line integral from minus 3 to 3 of x squared dx, which gives us an answer of 18. Now we need to do the line integral, but for C2. C2, however, is half of a circle. When we are looking at circles, we generally want to change it into polar coordinates. When using polar coordinates, we are going to replace the x by r cos t, the y by r sin t. So if we have x squared plus y squared, well then that would give us r squared cos squared t plus r squared sin squared t, which is simply just r squared. So for C2, we know that we're going from 3, 0 to minus 3, 0. We're going to place x as equal to r cos t, r being the radius, which is 3, so 3 cos t, in which case dx is minus 3 sin t dt. And if y is 3 sin t, well then dy is 3 cos t dt. Finally, if we replace the x squared plus y squared in the f that we were given at the beginning by the x and the y that we found, and the dx and the dy's by the ones that we found, we get 3 squared times minus 3 sin t dt plus 3 squared times 3 cos t dt. But now it's important to realize that for the line integral, we set it as 0 to pi. When we're using polar coordinates, we are going to use the angle that we have in our circle. So if we look at our circle, we are going from angle 0 to angle pi. Pi is like saying 180 degrees. We're going to pi. So we're going to go from 0 to pi in this case over here. Once we calculate the line integral of C2, we get a line integral of minus 54. Finally, when we're asked to find the closed loop integral? Well, we simply have to add the integral of c1 plus the integral of c2, which gives us 18 minus 54, which is minus 36. Since it's minus 36 and it's not equal to 0, it is not conservative. Thank you very much. I hope this was helpful. Please leave me a like and subscribe, and I'll see you in the next video. Have a good day.